We just introduced the new Framework Laptop 16 with the new Ryzen AI 300 series processors and the new NVIDIA GeForce RTX 5070 graphics. We actually started developing this product at the beginning of 2024, right as we started shipping the original version of Framework Laptop 16. And of course, as soon as we started shipping, we read every press review, we watched every video, we went through the community to see what people were talking about. We ran post-purchase surveys on people who picked up the product early to see what they were talking about. We went into our customer support channels to see what people were coming back with when they had issues. And all of that is what drove the development of the new generation. And obviously, whenever we start out a new product or a refresh or set of upgrades on one of the products we already have in market, we start really broad. That's like an enormous funnel of information that's coming into us. And then as we go through that design and development effort, we figure out what's actually feasible in that generation and what's something that we have to put on the back burner and maybe explore for the future, or that we figure out is actually just like totally infeasible. And most of the time, obviously companies do this. Every company does this when they're building a product. Most of the time, that stuff that doesn't end up in the product ends up incinerated somewhere, locked away in a filing cabinet, obviously never to be seen again. We are going to try something different. We're actually going to walk through basically everything that we tried out on Framework Laptop 16 in this refresh cycle and talk through what didn't land, why it didn't land, and maybe some other things that we're going to explore to try to land it in the future if we figure out that it's still important to do. So we're going to go area by area. And the first one that we're going to start with is the touchpad row. This is something we've gotten a lot of feedback around. There are scenarios, and especially for some of you out there who just have specific ways of resting your palms or your arms on your laptop. We know you don't like the multi-piece touchpad row. And so this is actually the first thing that we explored, trying to find a way to improve on. And so we designed this prototype, which is actually functional, although I think this computer might be dead, just out of battery. But we tried to replace that multi-piece touchpad row with a single extra wide touchpad. And the reason this is extra wide is that we wanted to have a single module that would work regardless of where the keyboard was positioned, whether it's centered to the left or to the right. Now there's an obvious challenge here. If the touchpad is this wide, and let's say the keyboard is offset to the left side, as you're actually trying to use the thing and type, your palm's resting right on it. And from a touch perspective, palm rejection algorithms are pretty good. Like you can reasonably detect when something's a palm or a finger and not trigger touch. But if you're resting on that, you're physically pushing on it, which is going to trigger the touchpad to actually just click. And so to make a touchpad this wide and this large actually function, we designed and developed it to be a haptic touchpad, which we know is also another thing that we've gotten a lot of feedback and asks around. So this is actually a very, very early prototype of a piezo-based haptic touchpad solution. This is maybe actually the largest piezo haptic touchpad that anyone's tried to put into a laptop. That's challenging on its own. But the other thing that was super challenging on this was trying to solve that palm challenge. And so the thing that we found as we were prototyping this is that as you rested your palm to try to just use your computer in a normal way, and then tried to trigger the touchpad by using your finger and clicking on it, that it was very, very difficult to disambiguate not the capacitive sensing, but actually the force pressure coming from your finger or your palm to be able to properly track that click occurring or not occurring. There is another challenge here, which is that if you're typing over to the side because your keyboard is offset and your touchpad is still here, you don't necessarily want this full area to be the active area, especially as you're thinking about things like where is your right click region if you're just tapping here. And so one other thing that we were experimenting with was actually shifting the virtual active area based on where the keyboard was positioned, and then doing things like showing haptic feedback when you're off region, like lots of different UX explorations we were doing. And we found that like in the happy case of like you're putting a finger around and just using it generally, it was working okay. But as you started to get into like real world usage scenarios, the overall user experience was just not working. So we shelved this thing, kept the original touchpad solution from our Framework Laptop 16. And this is something that we are going to continue to explore and iterate on and try to find some solution to make it work. And one other thing on this, obviously, there's like a lot of technology going in here. This is also CNC aluminum as a polymerized area here. This was super expensive, which we also know is not necessarily something that everyone wants. And so this is something that we're going to keep iterating on, hopefully at some point in the future find a better solution for. There are a couple of things we did still do on the touchpad row to improve it. One is that our supply chain team and quality team especially, along with our mechanical engineers, have worked with our suppliers to really improve the flatness spec on both the touchpad module itself and on the spacers that go around it, to avoid scenarios where there could be offsets between the two that could maybe result in you feeling that edge there more than ideally you would want to. So that's one improvement that is going in. And the other thing that would be fun, that we thought would be fun, was that we actually saw some cool projects coming up in the framework community where people were designing 3D printed single piece solutions for that bottom row, which then of course lets you 3D print custom positions based on where you want to use that touchpad. And we decided to actually just make our own version of this off of our official CAD. And so Carol and our mechanical team just quickly pulled this together. We're still refining this a little bit, but we will publish this on GitHub so you can download and 3D print it. And actually this ended up being a lot more comfortable and usable than we expected it to be. So it actually does just slide right into that bottom row. And this 3D print was a little rough, so these tolerances might not be perfect here. But you can just click it in and use it as a normal touchpad. It ends up working surprisingly well, actually. So it was a DIY-friendly solution to single piece for now, and something that we'll keep investigating for the future. Another one that obviously we've heard a lot of, especially as we released the new Framework Laptop 13, was translucent bezels. And I don't blame you. This looks super cool. We all want this. I want this too. The challenge that we found as we tried to apply translucent resin to Framework Laptop 16 is actually just this geometry here is very, very challenging to injection mold. There are a lot of big, flat, very thin areas here. And to make this translucent, we're actually using polycarbonate instead of PCABS. Polycarbonate is a lot more brittle, especially when you're using post-consumer recycled material for that polycarbonate. And so basically, as we actually made prototypes in polycarbonate of the bezel, which unfortunately I couldn't find offhand, as you tried to apply it or even bend it slightly, it would actually just shatter. And if you look at this PCABS, you can see it's like super floppy. You can bend it, all the way 180 degrees and nothing happens. So this is just a lot more durable and compliant in a way that makes it more durable for this use case. This is another one that we're not going to give up on. We're going to keep looking for other types of resin, other maybe post-consumer recycled polycarbonate blends that are a little less brittle, or even slight adjustments to geometry to try to make this work in translucent. Hopefully something that we can solve in the future. One other one, if we get into the internals of the system, is memory. Something we've consistently been surprised by, but really maybe we shouldn't be surprised by, is just how much memory you all want. So last year, I think it was last year or late the year before that, we introduced 48 gig modules, and the attach rate on 48 gig is actually enormously high. We actually sell more 48 gig sticks than we do 8 gig sticks, which is probably we're the only PC brand, notebook brand at least, where that's the case. And so our assumption here is that you want even more memory. So 96 gigs is not enough. You want 128 gigs. There actually have been some higher density memory parts that have come around. And so we early on found our supplier AData, who we use today for memory, a solution that they had upcoming to use what are called CSODIMMs. They're clocked SODIMMs. They actually have an extra IC on board that actually is mostly to enable higher clock rates. But in this case, they had designed this module also with 64 gig capacity. We tried it out. There is not official support from AMD for CSODIMM, at least on the generations of processors that we use. We figured we'd try it anyway because sometimes things happen to work anyway, even if they weren't originally designed to be that way, and found that actually it just does not work. to put a CSO DIMM into Ryzen AI 300 series, it actually ends up running at around half speed. So a huge hit to bandwidth. That's not something that really makes sense. So we decided not to proceed on that path. We did very recently find that Crucial actually does make a non-CSO DIMM, regular SODIMM, DDR5 64 gig module. We did just some very basic tests on this and it did function. We obviously want to do a lot more validation effort since as far as we know, these haven't been specifically validated by AMD on this platform before we make any kind of like broader recommendation on using this. But if we do find that these work, which hopefully they do, that'd be great, we'll go ahead and update our knowledge base information and potentially even bring this into our marketplace as something that we sell as well. So that was one that's likely actually going to come in the future, these non-CSO DIMM high density 64 gig modules. So you can get 128 gigs. Okay, input modules. That was the next one. Something that we hear over and over again across our entire product lineup is that people want pointing sticks. You might know it as track point from other brands, the little nubs that you can use as a mouse. Obviously, if you're a ThinkPad user, former ThinkPad user, that might be something that you're very familiar and comfortable with. And so it is something that actually on all of our products, several times over the last 5 years, we have tried to prototype and make work. The big challenge on this actually is just that there's very little space here. The Z stack here is incredibly thin. And for a keyboard, it works because the keys are compliant. If there's force that's put on the lid, like let's say you've got your laptop in a backpack with a book or something just being pressed on like that, the screen is going to touch the keys, and the keys are going to give way because they're just on these scissor mechanisms, and the screen will be okay. And you make it a little smudge that you have to wipe off. You've got like finger grease on there. Pointing stick though is not compliant in that way. So you've got this like sharp point basically sticking out from the keyboard, and if there's pressure placed on the lid, that's going to go right onto that point on the tracking stick and end up damaging the screen or have a high likelihood of damaging the screen. And so we've just kept over and over, we've kept trying this and seeing if we could get a low enough profile pointing stick solution to make that work, not risk the screen at all. And so far that doesn't exist. That is something that we keep going into the supply base to try to find. Hopefully that is something we find in the future. Because of course, with this input module system on Framework Laptop 16, it would end up being relatively straightforward for us to just make an input module, a keyboard that you can swap in that's got that pointing stick. Unlike even our other laptops where you'd have to have an entirely new input cover to get that kind of functionality. Also on input modules, one other cool thing that we have shown off and we've actually talked about even at our launch event earlier this year is the one key module. So this is a module that lets you develop custom input modules. Like we showed off this ortholinear keyboard. This is actually a functioning mock-up that we showed at the event. This is still in progress. So this is not we tried and we couldn't get it to work. This is actually this is working. It's taken a lot of work with our suppliers to make it work. And we still need a bit more time on this to get it mass production ready. And part of the reason for this is that even though structurally from a mechanical standpoint, we're using the same keycaps, we're using the same internal plastic parts as we do on our regular keyboards, the rest of the mechanical structure and the entire fabrication assembly process is very different than what goes into a keyboard because it has to be separable by individual keys. And so this little dome here, for example, ends up being hand placed piece by piece as opposed to having a single membrane that applies across the entire sheet, which is just much simpler. And the mechanical structure overall is just very novel and something that our suppliers obviously are working very hard on with our mechanical team and supply chain team. And part of what we've been doing over the last few rounds of iteration on this is really focusing on bringing up the manufacturing yield so that we can make this available at a reasonable price. If you're building a keyboard, you'll need literally like 100 of these things. So the cost really starts to add up if the per key price ends up being high. So that's something that we are iterating on now. And obviously, as soon as this is in a place where it is MP ready, we'll start seeding this out to a few developers. and then we'll make an announcement and make it broadly available through the Framework Marketplace. And we've got one last one that also is actually in progress. So not something that is on the back burner, something that we're actively developing. When we create new modules, especially major upgrades like this graphics module with the new NVIDIA version that we are releasing right now, we want to make sure that upgrading doesn't result in generation of more e-waste. So on our Framework Laptop 13, for example, when we did a new mainboard generation, we introduced that Cooler Master mainboard case, so you can use the mainboard on its own. We want to make sure that there is a pathway to reuse graphics modules coming out of the Framework Laptop 16 rather than them going and sitting in a drawer, or worse, going out into a landfill somewhere. And so back in 2023, actually, when we first announced the Framework Laptop 16, we showed this very, very early prototype of an eGPU where you could slot in a graphics module. We've kept developing this. What we realized actually fairly early on is that it didn't really make sense to build this like incredibly polished, very consumer ready eGPU, because it just drives the cost up by a lot. So the mechanical parts here, also what we've done electrically, even on this prototype, it is just a very expensive path. And to make sure that that reuse scenario like actually logically, realistically makes sense, we knew that it actually has to be much, much cheaper and much, much simpler. And in doing so, actually not be really consumer targeted as a general purpose eGPU, but actually more something that is DIYer, builder, maker focused as the starting point for people to build on top of for different types of projects, and really still be able to reuse and leverage those graphics modules. So this is something that's actively in development. As soon as we have something to share on this in terms of the actual final product solution that we're going to deliver, we will share more on it. That is something that is not going to be in the next few weeks, but is something that we are actively developing and hope to share more on soon. So that is everything, all the major stuff anyway. There are probably some other smaller things that we did try out that didn't quite make the cut. We did get a lot into the new Framework Laptop 16 between the graphics module, display outputs, the keyboard firmware and keyboard artwork, the new mainboard generation, and the new top cover with the new CNC geometry. So a ton that we were able to pull off. The team did awesome, awesome work on this generation. And we've got a bunch of learnings from all of this stuff that's going to continue to pay off in the future as we continue to build new versions, really all of our products. So that is everything. I hope that helps you understand a bit more about what goes into making products that are this complex. And I actually don't really need to ask this because I know you're going to do it anyway, but definitely please leave comments below with anything else that you would like us to try out, whether that's on the Framework Laptop 16 or on any of our other products. Thanks.